So this is the 2019 AP Calculus BC and AB free response question number 1. This is calculator active question. And it says, fish enter a lake at a rate modeled by the function E. Fish leave the lake at a rate modeled by the function L. Both E and L of T are measured in fish per hour, and T is measured in hours since midnight, where midnight is T equals 0. Part A says how many, actually before we talk about the individual parts, this is a calculator active question, right? So what I'm going to do is define each function on my calculator. Define E of T is equal to 20 plus 15 sine pi times T divided by 6. And define L of T is equal to 4 plus 2 to the 0.1 T squared. And now that those are defined, we can work the problem easier, so we don't have to write out the function every time we do something. Part A says how many fish enter the lake over the 5-hour period from midnight to 5 a.m. Give your answer to the nearest whole number. So you have to integrate the rate that they enter the lake from 0 to 5, simply because integrating the rate gives you the change. So part A, this answer is the integral from 0 to 5 of E of T dt. And you could leave it as that, since that function is very clearly defined. So we're going to integrate from 0 to 5 E of T dt. Convert that to decimal, which gives us 153.458 fish, and it says to round to the nearest whole number, so we're going to say 143 fish, or 153 fish. And that's it for part A. And part B says, what is the average number of fish that leave the lake per hour for the 5-hour period from midnight to 5 a.m.? This is simply a finding the average value of the function L of T. Since L of T is the rate that they leave the lake, it's asking for the average number of fish that leave the lake per hour, so the average rate that they leave, and the average is 1 over the interval times the integral over that interval. So it's simply this answer. You put in the bounds 1 over 5 minus 0, the integral from 0 to 5 L of T dt. That's just a formula you should know cold. 1 for 5 minus 0. We'll put the decimal there so it gives us an answer in the decimal place, times the integral 0 to 5 L of T dt, which is equal to 6, how's it be 6.059, and it's the average value of L of T, which is in fish per hour, so this is fish per hour. That's your answer for part B. Part C says at what time T, for T is 0 to 8, is the greatest number of fish in the lake. Justify your answer. So the first thing here is we could check at one point it's at the derivative of the number of fish is equal to 0, right? And the number of fish as a function of time is going to be the initial fish, or the number of fish the number of fish at time T is equal to the initial amount of fish, and they don't really give you the initial amount of fish. I'm assuming you don't need it. You definitely don't need it, actually. So we're just going to ignore the term. So the number of fish as a function of time is going to be the integral from 0 to T of the rate in minus the rate out. Putting x's here just to not mess with the variables. So the derivative of this is going to be e of x minus L of x, and this has to equal 0, where it's a maximum or minimum or some sort of relative extra. So we can use our calculator to solve where that is equal to 0, or rather, this isn't x's, these are t's. E of t minus L of t equals 0 at a possible maximum. So at a possible maximum, E of t equals L of t. And we're going to simply use the calculator for this. You could use a graph, you could use your numerical solver. I'm going to use my numerical solver. Numerical solve E of t equals L of t comma t, and it gives us a negative solution. That's awesome. Let's see if normal solve gives us. So it gives us many solutions, and that positive solution is equal to 6.204. And we have to check the endpoints, right? So this is a possible candidate. T equals 8 is a possible candidate, and t equals 0 is a possible candidate. So we have to check them at each time. So the number of fish at this time is equal to the integral 0 to 6.204 of the rate in minus the rate out with respect to time. This is equal to 0, 6.204 E of t minus L of t dt. That's 135 fish. Again, it's a fish, it's a discrete quantity, so it's best just round to the nearest whole number. And for this one, the number is equal to the same integral, except with a bound of 8. E of t minus L of t dt, and this is equal to, we're just going to copy and paste this and replace the bound, 81, and this is simply just 0 because any integral that has the same upper bound and the same lower bound is going to be 0. So the maximum amount occurs at time. Max amount at time equals 6.204 hours. And you justify that by saying the amount at 6.204 is greater than the amount of 8, which is greater than the amount of 0, and show that you checked your endpoints and show that you set the derivative of the number of fish equal to 0 and solve for that possible maximum. Part D says the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m. Explain your reasoning. So this wording is stupid, in my opinion, and I also got this wrong because I misread it. It's not asking if the number of fish is changing or increasing or decreasing. It's asking if the rate of change of fish is decreasing. So you have to take the second derivative of the number of fish, which is just the first derivative of E of t minus the first derivative of L of t. And again, it's asking if the rate of change is increasing, not if the number of fish is increasing. So this is E prime of 5 minus L prime of 5. This is equal to t minus L of t such that t equals 5, which is negative 10.723 fish per squared hour. I'm sure you don't need the unit here. It's kind of a confusing unit. So decreasing because this quantity right here is negative. There's no real explanation to it. So yeah, that's question number 1.